can give you just a little bit of an overview of what it's like to develop with and for the open web device, FirefoxOS. So at first, we're going to take a sort of a very brief look at sort of the application infrastructure that we are trying to put in place. The web right now is great for individual websites, and that's great for when people know how to use a browser, but on a mobile device, people expect to have apps. People expect to have an application experience. And that's something that doesn't exist right now, or it is starting to exist in some places. Google is developing something like this a little bit with the Chrome store, and we'll see how that goes. But it is very Chrome-centric, and as Andreas tried to explain earlier today, Mozilla always tries to make something that works for everybody. And so we'll take a little bit of a look at that infrastructure and sort of how you can publish a website as a web app. And then after that, we're going to take a little bit of a look at how to actually develop with the APIs that are new to the web specifically for this device. And we're going to take a little bit of a look at the tools you have available as developers to work with the device, or even if you don't have a device, how you can try and get your application ready for the device. But this is just an overview, and I hope that we have a lot of time for your questions. I'm here for you, and there are probably topics that interest you that we haven't thought of and we haven't covered. I'm a developer just like you guys. If you guys want me to show you something, if you guys want to hack on something, if you guys want me to demonstrate something, I have all the code here. We can dive right in, right? So please don't be shy. Please don't be afraid to ask any questions, or say like, hey, how have you solved this problem on the phone? And then maybe I know, maybe I don't, but we can find out together. And so hopefully we can make this as interactive as we can. OK, cool. So we have a little bit of time before we're going to pause a little bit for some coffee, because I'm sure everybody's already very excited about recaffeinating. OK, so let me pull up the real slides here. Yeah, this is it. OK, so here you see basically what it looks like when you switch on the phone. I have one of my development devices here, and I can unlock the screen and go to the home screen, and you see basically what you see in big there. You see a bunch of apps, and you see a home screen I can swipe, and all of that is written with web technology. This is a website, right? And which is pretty cool. And basically the idea is we're going to find out how to do that. How do I get my website onto this screen as a web app, right? How can I take my website and make it an app on the phone? And the key component to this is something that Mozilla calls open web apps. And so literally translated, aplicativos de web abertos, and but the term open web apps is really something we want to try and coin, is the idea that on the web nobody can stop you from publishing a website, and in a lot of app stores right now, people can stop you from publishing an app. Like Apple can say, no, this iOS application you've written does not conform to our guidelines. Chrome could do the same, etc. And maybe I see some people are nodding, and this has happened to a lot of people, that at some point your application gets rejected and stuff. And on the web, everybody's in control, and so that's why we feel when we talk about web apps, we want to make sure that we talk about open web apps. A lot of this infrastructure is explained on the Mozilla Developer Network. a website I can highly recommend if you're a web developer. So if you want to, if you have any questions about anything in here after today, it's very likely that technical questions especially, it's very likely that they're going to be answered on MDN. And so what I typically do is I just Google MDN and then the question I have. So for instance, open web apps, right? And typically the first hit is just going to be the answer that I'm looking for. And indeed, this site, this page tells me everything about I need to know about writing apps. And I can start learning about these things. And we're just going to take an in-depth look today. Okay, so basically an open web app is a website. So you start out with a website. And then, and the great thing is about starting out with a website, who here is a web developer or knows how to develop for the web? Yeah, that's most of you, right? So you can start in a familiar environment. You can start on the desktop. Thank you. You can start on the desktop and use all of the tools that you have available on the desktop, and we'll look into those later on. And then you basically package. All you have to do is add some packaging material, essentially, to make it work on the phone, or to make it as a work as a web app. And so basically, the steps, the sort of the recipe, if you will, is you develop your website, your web app, using the technology that you're already familiar with as a web developer. Then basically, a very simple step, you create a manifest file that describes your web app. And then you use that manifest file. When you're developing, you basically use that manifest file to install it directly on the phone. And when the time comes to publish your web app, you can use that manifest file to either self-publish. And so this is one of the great things about open web apps and about the web, or that something that open web apps preserves about the web is that self-publication. Something you can't do with iOS, really, or Android. Or Android you can, if your users have checked that box or whatever it was. But actually being able to self-publish an app. Everybody on the internet can self-publish their website, so why shouldn't they be able to self-publish a web app? Or you can submit it to a web app store, and so Mozilla is going to host one marketplace for open web apps, but we hope that other people will also be hosting and creating stores and marketplaces for open web apps. So this is the step you're already familiar with. If you're a web developer, you create an HTML5 web app. And then this is the interesting bit, the bit that is kind of new, is you create a manifest file. And the manifest file basically describes everything the phone needs to know about your web app so that it can display it on this home screen, essentially. Basically what this file is it's a text file with a .webapp extension, and it looks like this. Or this is an example. It's a JSON file. Everybody, if you're a web developer, you'll be very familiar with JSON. It's essentially just a JavaScript object. What this does is it describes the name and the title of the application, the icons, and so this is a lot of it basically revolving around how it gets presented on the device. But there's also a lot of more information in here that describe the installation process and later the permissions and so forth that the application will have. So a lot of the stuff as in terms of what the runtime environment of the app that is also important. So one of the interesting bits is where are you allowing the application to be installed from, which is interesting if you're self-hosting or if you expect to be installing it from a marketplace. An interesting bit is if, in terms of runtime environment, is a lot of you are probably wondering, well, if I'm writing a website, if I'm writing a web app, and I'm expecting this application to be installed on the phone, then how is it supposed to work if the user doesn't have an internet connection every single time, right? And so obviously the idea is that the entire web application gets cached on the phone. So what Gecko will do is the minute you install the web app on the phone is it will download all the resources from your website, from your web server, and put them on the phone, cache them on the phone, and then periodically it will update. Do you have a question?
I don't know if
yeah.
can ask questions.
Yeah, please. If you have a question, feel free to ask it.
So it will download the application resources to the phone?
Yes.
This will be packaged in some way, or will be protected in some way, or is just like the web where it will be stored on the phone and the user can get access to these resources anytime he wants?
So I'm going to repeat your question. The question is when Gecko downloads these resources, how are they stored on the phone? Is that correctly?
Yeah.
Do you have access as a user? And
yes.
okay.
If the resources downloaded will be protected
Whether they'll be protected in some way. So the mechanism that Gecko uses is called app cache, and the way app cache works is they are downloaded they're basically downloaded to some database somewhere. The user never sees these, and for the web app, for the web app, it's completely transparent as well. So yes, the resources are loaded from a file locally rather than the network, but to the web app, it thinks it was just downloaded from the website. And in fact, when you ask for window.location, or you want to make an XML HTTP request, your security context is always your websites, yourwebsite.com or .com.br or something, right? So so yes, there are files on the phone somewhere, but they're not accessible to the user. Does that answer your question?
Yeah.
Okay. You had a...
Yeah, I want to add a couple of words to that. So another question we often get asked is whether the web is more unsafe than, like, let's say Android, for example, because JavaScript is in source code form, right? So it's easier to understand what JavaScript does and whether people can steal your web application easier. So as Philip already said, these offline cached resources or installed applications, they're installed in a part of the system that is not accessible through device storage. So the device has two storage areas. There's an internal storage that's built into the phone, and then we can store on SD cards. So all your media and videos and pictures go into the SD card, and if you plug the device into your desktop PC, you can see those files. Applications do not go into the SD card. They go into the built-in storage, as Philip said, in some database. They're locked away. That's where the applications live. So first of all, when you download them, they go into the device storage. But also second, actually, Java or Java bytecode and JavaScript are actually not really that different. So I think people often misunderstand the protection that Java bytecode gives you. If you have a Java application as bytecode, you can very easily transform that back into source code. So the translation from bytecode to source code in Java kind of works in both directions.
Might not, it's more about the resources. Because we work with the newspaper, and we have downloads from printed edition, some kind of PDF or stuff like that. And this is charged, so the user downloaded. It would be really bad if we would have access to this PDF.
So the question was, this specific application problem here was downloading newspaper contents and offline caching newspaper content whether people are able to like take those documents, if they're PDFs, for example, just kind of extract them from the device. That would be bad because this is purchased content. We want to protect this on the device. So we are basically offering a solid level of protection. If you offline cache something, it's stored in this internal device storage that is not directly accessible to device storage, and you have the content in there. Now, to be fair, this is not meant to stop a hacker. So this device has flash storage in there. If you use a debug protocol to open up the device and the OEM sold the device with the debugging port enabled, or if you physically open up the device and kind of like solder something onto the chip, you will get to the PDF document. So this is not military-grade protection. What we offer is for users in the average use case, there's no way to get on these documents that you offline cached in an internal database. You can always get to it. You can also get to it in iOS and Android, basically. So we were trying to offer roughly the same experience for developers and content providers that you get in other smartphones as well. Does it make sense?
Yeah.
Okay.
And I think we're breaking now for coffee. But just to add to your question, so if you want to, so the app cache is mostly meant for your code, for the HTML, for your JavaScript, for your CSS. If you want to actually cache content, it might not be the best solution for you. There's other solutions, things like IndexedDB and stuff like that are great for actually caching data. We can look at that later if you want. But it is essentially stored in the same way. It is not accessible using USB device storage or something like that. But if people want, they own the device. If people want, they can get access to it. But yeah. Yeah, the average user, and it is not available to other applications. So if your application locally caches contents, it stores data, other applications cannot load it because they each run still as if they were websites, right? So yours would run under newspaper.com.br or something. The Open Web App Manifest, which is a JSON file. And yeah, some of the information in that JSON file relates to how it gets presented once the web app is installed, or how it gets presented in a marketplace or something in a listing. So for instance, the description and the name is when you want to search for the app in a marketplace or something. That's very useful. And the icons, of course, when you want to display it on a home screen. And then we started diving into some of the more technical parts. So we were talking about the app cache. And so, as I was explaining, one of the things you don't want to do is every time the user opens your application, what happens is that it gets downloaded from the web. That works right now on desktop, because on desktop you typically have a fast internet connection. So every time you open Gmail, what happens is that everything will be downloaded from the web, unless the desktop actually maybe caches the JavaScript. But you have very little influence over that. So with the app cache, you actually have, there's a separate manifest where your application can tell the device which files to save locally. And then the device will periodically check for updates of these files. And that's a great way for you to roll out application updates as well. It's entirely transparent to the user. There's no separate download process or something, but it's simply updating the cached files locally. And then we have one piece that's missing here is permissions. So one of the things that is kind of new to the web platform with a device like this is that these devices have a lot of capabilities that a desktop computer doesn't necessarily have. One of them is geolocation. That's actually one of the few things that also the desktop has. Maybe the camera, maybe audio, playing audio, recording video, using the phone on this, reading and writing certain properties on the cell phone radio, sending SMS text messages, all these things, configuring the system stuff. And some web applications need to have these capabilities. For instance, the settings app, the app that will actually let me configure this phone. That's a web app. So it needs to have these capabilities, but a lot of other applications do not. So basically, this one work? This one's working, yeah. So basically, when you see these applications, they each basically get installed with different capabilities, different permissions. So for instance, the Contacts app here needs the ability to talk to the contact store on the phone, but it doesn't need to have the ability to talk, to make TCP connections or something like that, right? And so that's why, as part of the manifest, you list the permissions that the app will require, and then that way we also do not need to ask the user once the application is running. Right now on desktop we ask the user, do you want to share your location? But it's kind of hard, every time you open the dialer, do you want to allow this application to use the phone? That's kind of pointless, right? So as part of the manifest, you include the permissions, and that leads us to another step. Is then, of course, well, what if somebody writes an application that wants the phone properties, right? And I could some hacker could write a web application that pretends to be a newspaper application, but really it just ends up dialing to China all the time or something. And so because that is obviously not something we want to happen, is there is for these kinds of permissions, for these kinds of capabilities that, for instance, telephone, SMS, etc., highly privileged capabilities, they need to go through a marketplace. They need to go through our marketplace, and they do need to go through a review process, right? So that is to ensure that these capabilities aren't being abused. And so, but on the other hand, if you are writing a newspaper app, you probably do not need any of these capabilities, and you can still self-publish. Right? So it's kind of a compromise to make sure that security is ensured for apps that do need privileged capabilities. And yet at the same time, if you don't, you can self-publish and you don't have to go through the marketplace. But of course, you can go through the marketplace if you want to do payments and things like that. So there's also a tool that is also linked from MDN. That's the manifest checker, to make sure that your manifest has all the minimum data points. There's a question back there.
I'm just wondering. I don't know if you guys know how many of current Brazilian developers that are targeting apps actually are thinking in making apps that depends on a specific device APIs.
So the question is, do we know how many Brazilian web developers or app developers?
How many of the app developers in Brazil they are currently?
Right.
I don't know. I don't even know. Like, I'm here because I have one app. I don't know the others. But how many of us actually are targeting to use the device APIs? Right.
Targeting to use device APIs. That's a good question. And it depends on the device APIs, right? There's and we'll like in the next session we'll go through these individual APIs, or at least some of them, and then you'll get a better idea. I feel like your question is really hard to answer.
No, it was inspired by your notes that you mentioned. You don't have to use the device APIs to write your web app. So I'm actually interested in knowing what's the reality in terms of the innovation market here. Are we? For instance, the newspaper guys, are they going to deploy only content that they have? They're making legacy services in this market, or are we actually here in this room or in your information of Brazilian developers interested in device APIs? So knowing that information is key.
Well, I think it's kind of a false dichotomy. I don't think there's one or the other. I think a lot of web apps will just be. They already work as there's a lot of apps right now that are written with the web as mobile websites that work very well, or using PhoneGap or something like that. And I think at the same time, there's no reason to not explore the new capabilities, right? I don't really see a like a conflict there.
It's also not a strict either-or decision.
Right.
So in many cases, what you will see that you have an app and you make sure you use the capabilities of the existing web that are broadly available everywhere. Like we call it the comfortable core of the web, like everything that's already standardized in HTML5 for some related specification. And that's the core of your application, and that works across every device. The point of these new web APIs in many cases is to give you advanced capabilities that you can detect. So you can see whether you have access to the camera, for example, for streaming video. If you have that, then you can add video chat via WebRTC to your newspaper application, so with your friends you can discuss an article. And you can detect this capability. If it's there, you can add its enhanced feature. If it's not there, you simply disable it. So you see in many of these new APIs that there might be applications that really rely on them. Like if you have an Instagram-like application, you really might need the streaming video API at all times. But most applications, I would expect that it's simply an additional device capability you can use. One of the APIs that Philip and I can talk about is device vibration, haptic feedback on the device. You don't need the API to make a game. But if you have some game where you're driving a tank and you're driving across a bridge, you can detect that you have a device vibration capability, and you can vibrate the device and provide some like more immersive gaming experience. So this is really not like, are people going to use these new APIs and how many people want to use them? It's simply that you can start building applications, you can target the existing APIs that are on the web, you can start adding new APIs. You don't have to trade off these two things.
Right. And in fact, feature detection is really handy for when the permission is not granted, because then you can gracefully fall back and do not use the capabilities if you're not granted. Does that answer your question?
So just a quick follow-up is, do you have a map of the current, currently, you have Brazilian apps deployed in your market?
I don't know.
Only one? So that answered my question. I was wondering, from the Brazilian maps in the market, I thought we had like 100 already or more. And then how many of those guys are using device APIs, because you could gather the information from the manifest. So I'm curious about the innovation aspect towards the device APIs.
We're only getting started, right? I mean, it's important to realize that there's currently no release of Firefox or FirefoxOS out there that supports all of this. This is still under development. I mean, this is a development phone, and everybody here who's going to start working on this. The great thing is we have a head start, right? We can develop with this now, and then once this hits the market, we are ready. So everything that's out there right now is people like us who get a head start and are at the cutting edge and are doing things. And in fact, like the permission stuff is has only been implemented very recently. That's why it wasn't even in the slides. So yeah, things are still being implemented. Okay, so yeah, coming back to the manifest. Basically, you before you publish your manifest, there's a way to verify that it is actually valid and contains at least the minimum requirements for the store and for Firefox. Then there's and then basically what you need to do is you need to host the manifest alongside with your web app. So with your website, on your website, you host the manifest. It needs to be hosted with this special content type, and there's explanations on how to serve it up in Apache and various things, which is interesting if you're a website administrator. And then you can test it using curl, for instance, to make sure that the manifest is hosted correctly. And the interesting bit really is then you go to the marketplace, and so this is as I said, it's still a preview. The marketplace is still being worked on. But basically, you log in and you submit your app, and then you publish your manifest there, and that's all the marketplace needs. You host the app, you host the website, you're in control of updates and stuff like that. All that the marketplace really does is it's a directory of manifests, right? And what you can then do is either you go to our marketplace on this phone. So there's a marketplace app. It says server not found because I don't have internet here. But basically, this is the marketplace, the same marketplace website, but packaged as an app. And then I can browse for the application and install it from here. Or I can also just, and this is the great part, I can also just install it. I can put an install button on my own website. So for instance, I can say if people go to the website using the browser in this device, say you're a newspaper, and people browse to the newspaper website in the browser, and then I can detect, am I installed or not? Actually, is this shown here? Do we have this? No. So let's look it up on MDN. So it's going back to let's see, going back to for web developers maybe. Yeah, it tells us. Installing and updating the app. There we go. And so, get installed. So for instance, here is an API that allows us to list all of the apps that are installed from our current location. So if I'm, for instance, newspaper.com.br, and I want to find out whether the user has my web app installed right now, I can use this API, or I think there was also a different API. Installation functions, maybe. Oh, this is that. For instance, get self as well. So get self returns an app object if you're installed, and it returns returns nothing, or you get the error if you don't have it installed. And so that's a great way to find out whether your website is installed as a web app. And then, if it's not installed as a web app, you can display a button. Install this site as an app, right? And this button, you can basically hook it up to this function. So you can say when the button is clicked, we execute this code that installs this app as on the phone. So you point it to the manifest. That's really all you have to do. I'm not even sure what this user stuff does. I've never seen that. And so and then you get a success and error and stuff like that. And then the next time, and then basically what will happen is the system will then say, hey, do you really want to install? You just click on a button that causes this app to be installed on your phone. Do you really want to do this? And then you say yes, and then you actually get an icon on the home screen. So I wish I had internet. I could show it, but I can show it maybe here. Oh, hang on. I need to launch this differently. So this is something that we will look at in a minute too. This is a desktop build of Firefox, of B2G. Oh. Here we go. So this is essentially the same build that runs on this phone, but it runs on the desktop. The great thing about Gecko is that because we have Firefox, we know that it works on Mac OS X and Windows and stuff like that. So we can kind of like package the same thing that we run on the phone. We can also package it for the desktop and run it. And so this is Gaia in a sort of very minimal way. See, there's no apps installed here. And so what I did once was I packaged some files up for testing some stuff. Report tests, I think. So this is a web app. It's just a bunch of files, right? Ooh, that's a fun bug. So, and here you see app.html. And I can now say install as an app. And what this button does is it does exactly this. It basically just calls navigator.mossapps.install. We can actually verify this by looking this up in see, we can look at the source code, and this is what it does, you know. There's a button here. We write a click event handler where we call the install method, and then it simply calls this with the manifest URL, and this is the manifest right there. And I think it used to be, this is before when, let's hope it works. I think we changed it from .json to .webapp recently, so let's see if it works. Install as an app. And so this is what happens, you know. So we're pretending we're on newspaper.com.br, right? And it's like, hey, I see you're visiting our website with a BGG phone, or FirefoxOS phone. That's great. Do you want to, you know, you're a frequent reader, and you know, do you just want to install this as an app on your home screen? And you say, well, yes, of course, I do. You click on the button, yes, install me as an app, and then Gecko does this. It says like, do you really want to do this? Because you know, it could be that somebody disguises some other button as whatever. And so this is one of the few times when actually Gecko will ask you like, do you really want to do something like this? And I say, yes, why not? It says, yay, success. You can install it from the marketplace. You submit it to the marketplace, this manifest, and or there's no, you don't have to do either or. You can do both. You can also have a button on or whatever means on your website to let users install it from your own website. So for instance, you know, Twitter or Facebook or anybody who, you know, you can imagine people go to that website and then they go like, hey, you know, this is something we can provide you with a much better experience if you actually install it on the home screen. And then you can, the great thing is in your app, it can be the same, it can be the exact same website, because you can detect using the get self or get installed methods. You can actually detect whether you're running as an installed web app or whether you're not, whether you're just running as a website. Okay, cool. So any questions about open web apps, manifests? If you do, come see us.
I have a question.
Yes, go ahead.
To top the application, what's the process?
Sorry?
You know, if I want to update my application,
right.
What's the process? What's the open web device in, you know, check how many times it checks if there is an update or not?
That is actually being written right now, I think.
Yeah.
Updates. So I'm not exactly sure on what. Can you display? Can you?
I can go into that. So basically, it depends how the application is packaged. So if you are not using any highly privileged APIs, you're just using general like web content. You're, for example, a newspaper application, a newspaper reader. You don't really use any privileged APIs on this device. Then you don't have to be reviewed by us. So when you initially submit the application, we will look at your application, but your code is not really certified by us. So basically, whenever the user installs it from your server, the code is downloaded. Every time you change code on your server, it is offline cached again. and it happens in the background. So if your newspaper reader starts, the device will go out to the web and check whether any of the files on your server have changed. And if they have changed, we will catch them again, and next time the user starts the application, the new version has rolled out.
Right.
So you have very fine-grained control of updates. It's basically like a website. Every time you update the website, all the devices will receive an update. Now again, this only works if you're not using any specific privileged APIs. So this is more like a traditional content consumption application. If you're using privileged APIs like the dialer, for example, or contact, where you can read the entire contacts list, those are packaged applications. So we'll talk a little bit about the distinction of these different packaging formats and how they relate to certain APIs. But when you package them, you have to submit them to an approved marketplace to get access to these highly sensitive APIs. And then you have to actually submit to the marketplace, again, the updated version. This is basically a security mechanism. In some cases, we think it doesn't really make sense to ask the user to make security decisions. So on an Android device, the device is going to ask you, do you want to grant access to the USB bus to these applications? Most people don't really understand what it means to grant access to the USB bus. I barely understand what that means. So we decided it doesn't really make sense to ask the user. Instead, basically, what we do is to install this kind of application, to use these highly privileged API features, you have to go through a review process in an approved marketplace. Does it make sense?
Yeah, that's something I failed to mention.
In Mozilla, it's not just the question, so the Mozilla Store has a submission process and a review process. This review is human-based, or is automated. Because in Google Play, you have only the automated process, and in iOS you have the automated process and the human-based process, and it takes about a week to publish an app. How will this work on the Mozilla Web Store?
So the question is how the Mozilla Web Store works and how the review process works. It's automated or done by humans, and what kind of timelines are. So first of all, most of you, if we make an application submitted to the Mozilla Store, will only go through a review once when you actually submit the application. Because you will likely not use any of the privileged APIs. Again, privileged APIs are things like the radio modem. I would bet that most of you will not make an application where you have to talk directly to the radio modem.
Well, maybe device storage. Well,
device storage. There's a few applications that make sense to have them packaged, and you have to do a review every time you update the application. But most of you, the applications you will make, they can be hosted by yourself, and you can update them on your own. So you only go through review initially once. And for that, we actually use a hybrid mechanism. So the store that you're seeing here is based on our extension store that we had for a couple of years already. And we have a bunch of tools for that. So when you submit an application, we do internal automated review first, and we can flag certain things that we consider high risk. And then a human operator will come and review the rest of the application and kind of comment on those high risk things that we have flagged. So there's an automated process backed by a human reviewer. The timelines I don't know exactly at this point, but it should be pretty quick. And for many of you, it should be only once when you submit the application, and then updates are owned by yourself. Was that a question?
Is there any kind of push notification mechanism on the device or operation system?
Yes. So we might get to this in the API part in more detail, but until then, yes. So we have basically a push notification API that we have proposed. This is a push notification API for the web. So we intend to implement the same API on the desktop as well, for example, on Firefox desktop, and we would expect the same API to kind of pop up all of our browsers. It's basically a very straightforward API. You can request from the browser, the website can request a token, saying, okay, give me a token, and if I hand this token to a specific server that the browser tells you, then the device will be notified at the other end that some event is waiting to be picked up. So it works conceptually very, very similar to systems you already have on iOS and Android. The main distinction is that we have actually jointly developed the infrastructure for that with Telefonica. So it integrates very tightly with the operator networks and eliminates a lot of the problems that notification systems cause currently on networks where many smartphones are operating on. So that we avoid some of the traffic across firewalls that create a kind of keep alive traffic that creates background noise on the network.
for a lot of companies, the payment process is like a big deal. We need to make it simple and trustable. For some devices, we can like save the credit card information as the mobile as a wallet, for example. How do you deal with this kind of information and this process of payment in apps?
So on the on the payment side, actually, so the question is, how do we deal with payments on this device? And I think there was a second question embedded in that. Is there any way to kind of store credit cards and things like that securely on a device? So actually, on the payment side, again, as this notification, this is one of the areas where we are working very closely with operators to integrate better these devices than they are traditionally. So on the billing side, we think that the main payment channel people want to use on phones is actually the operator billing part. You don't want to enter your credit card numbers with this like tiny display and store your credit card on a device. Also, in many markets like Brazil, many people do not have credit cards actually to begin with, or at least not international credit cards Mozilla could charge directly. So instead what we do, we have integrated this Telefónica's billing system. And there's a new API that we have proposed. It's navigator.pay or mouse pay. And basically, the website operator can create a little token that describes the virtual good you would like to sell and the price of it. And then in the browser calls this API. And the device opens a little dialog that says, do you want to purchase this? And if so, we will contact the server that's operated by Vivo and Telefonica and their billing subsidiaries. And it will appear later on your statement if you agree to or if you consent to buy the application. So we think that this is going to be the primary payment mechanism on these kind of devices. It is portable to other payment methods. So the same system supports, we have, for example, at some point also integrated with PayPal. There's other credit card processing entities we can integrate with. But we believe that most people will probably prefer to use operator billing since it's the most convenient one.
Okay, but if I have, for example, a form to purchase a product, and I can via API make this payment, or
Oh, you mean like I'm in the
will,
store?
This will be like approval or not, depend of.
Oh, so yeah, so the payment API actually is not privileged since there's a user confirmation. So the goal of the payment API is also not tied as necessarily to apps. This is just for the web. We have proposed a new payment standard for the web. How the browser can facilitate payments for you.
Okay.
And like Amazon.com could use this to sell you goods directly and integrate with payment channels on your device. So initially when this device shipped, as I said, we mostly expect integration with operator billing, but you can also link like credit card payments and other kind of channels into the same mechanism.
So I think I missed one part, but so the deal for charging in the telephone bill it's you were sure about that, or that's still under development?
So we are very sure that it's needed. We basically, from what we understand, many of the markets we want to launch in, as I mentioned in the earlier parts of my talk, we are trying to go right now towards a segment where there's large number of people with feature phones. They want to upgrade to a smartphone, and you find large populations of feature phones where people cannot yet afford a smartphone or cannot afford a really expensive smartphone in countries with growing economies. And in many places, credit cards or kind of the traditional US-based payment methods that like Apple and Google have based their system on are not as available. So in the Brazilian market, we don't expect credit card payments to be as relevant as operator billing. So we simply believe that we must do operator billing to really have a competitive payment channel people really want to use. So we have been working pretty closely with Telefonica and their payment subsidiary, Luvia, to integrate the payment piece. So the goal is when this device launches, you have via Navigator.pay or Mouse Pay, the integration with carrier billing. Most of the pieces are already available. You can actually, that's one of the advantages of this open source project. You can actually look into our bug tracking system. You can find out exactly the status. So last I checked, the pieces for the device are already ready, and we are waiting for the pieces on the server side, the actual server infrastructure, to be stood up and created. So by the time this launches, hopefully it's all going to be in place. Right now, you can see the way it's being engineered.
The operator gets a share about the goods, digital goods you purchase.
So I think the question is about like revenue sharing between the, yeah. So these are commercial terms. So the question was to what kind of share the operators and potentially the payment providers take from the actual purchasing price. So these are commercial terms. They are not completely finalized yet, and also this is one of the few things I cannot talk about publicly, since this is kind of basically a business interest of the operators and the payment companies.
They will have a share.
They will definitely. I would expect them to do a share.
But you can use any method of payment if I have, for instance, a payment system implemented on my end of the app, I can use it without a problem inside the marketplace.
Okay, that's a very good question. So the additional question we have here is whether it's okay to use other payment channels than the one we provide. And the answer is absolutely yes. So the reason we are providing a payment channel is because we think there should be competition. Multiple people should be able to offer payment channels. So in our marketplace, we are not locking you into using only on the payment channel. Many other systems do. So in Apple's iOS, very famously, you cannot put in applications in the marketplace if you try to sell things directly through your own payment channel. So we have no interest like that. Remember what I said about Mozilla's goal for this project. The goal for this project for us is to create an open web environment for mobile devices. Mozilla is a non-profit foundation. We have no interest in making money off this. We generate some revenue to the scale of it because we have certain business relationships, but we use that money to make the platform. We don't really have a profit interest. So as a result of that, you're more than welcome to use your own payment channels. You can implement it directly. So if you have a newspaper, for example, if you want to collect a credit card and bill people directly, please do so. In addition to that, we can also help you at a more strategic level. We want to integrate more payment providers into the proper payment APIs. So we think down the road, these devices should come with multiple payment methods where you can link your credit card and your phone statement and maybe other other direct banking, billing, whatnot. And then your user has simply choice what kind of API they want to use. So we are trying to help you get as many payment channels available in your application as you can, and there's no interest on our side to kind of lock you into a specific one.
Last one about this is, do you have anything on subscriptions with the phone bill? Because I really think it will be an excellent idea, but Google Play implemented subscription a little while ago. Apple has been doing since the Apple Store is up. You're looking into subscriptions via phone bill?
We are building this API incrementally. So many of the APIs we're actually building, we try to build the smallest possible piece, and then we add pieces on top of that as we make it successful. So for the initial launch of the device, we're targeting 2 use cases. You buy an application in the marketplace using this API, so you can upfront charge for the application, or you can make purchase inside the application. So in that, you as an app developer, you can charge in addition to the purchasing price, or which might have been free in the beginning. So subscription is the third one. We will probably not have it available initially when the device launches, but pretty shortly after the launch, we want to expand this also to subscription services as well. So basically there you would just say that I would like to charge you once a month, a certain amount. We would basically just extend this on the payment channel. This is something we have not currently added to the scope for the version 1 of the device. Maybe it's also a good time to talk about our general upgrade strategy. So with this devices, our goal is to update pretty frequently the operating system on these phones. So every 4 months, we will roll out a new version of the phone OS. And this usually means that the Gecko piece and the Gaia piece have to be updated. And we will make those updates available to the OEMs and operators to actually ship these devices to consumers. So as long the operators and the OEMs are okay with taking the new version and testing it on their older devices, people can actually very easily keep up with this and add these new features along the way as the device is being used in the market. Any other questions? What?
Okay, cool. Well, we have 5 minutes before lunch, so I guess we can start by looking at. Oh no, I wanted to just. We can start by looking at some of the some of the APIs that we have available, and then sort of give a high-level overview, and then after lunch, Andreas will sort of dive into some of them. So this is just an overview of some of the APIs that are available. One of the we're still working on some of them, like Andreas said, the payment API, for instance, is being developed on right now. And some of these are still changing a little bit. Again, we're trying to keep the information on MDN up to date, and MDN is sort of the place where you want to where you can get all the information and the latest information about all these APIs. And some of them, because they're still being worked on, aren't even on MDN yet. But we will, as we finalize things, we will put things on MDN. And so, to give you, we basically wanted to give you an overview of what these APIs look like. Even though, some of them might not be, some of them you might not even use at all at some point. Like, I expect very few of you to actually use the telephony API, because usually on a telephone there's only one application that makes phone calls, maybe one or two. But I think it's interesting to see that it's possible and what it looks like, and sort of there's common concepts among all these APIs. More interesting is, like, for instance, if you're writing a game or if you're writing something that is very interactive, is, for instance, vibration APIs. Interesting, for instance, I think personally is for sharing information between phones is the SMS API. Like telephony API, I expect there's only like one dialer, but I think SMS, for instance, would be a really cool. It can be a really cool way for two phones to kind of interact with each other programmatically. So, for instance, especially because SMS is very cheap. A lot of dimes now. I'm not sure how it is in Brazil, but a lot of times SMS are either free or you have a flat rate for the day or something like that. And there's, I, for instance, use a lot an app that shares my location with somebody else, but all they get is an SMS. So the app actually sends an SMS. And this works on Android, and so why should it not work with a web app, right? Things like that, sharing information between two people when you don't really need, there's no need to disclose information to the internet. You can just directly communicate. So that's really cool. Idle API is another one where something that really wasn't necessary on the desktop, because the desktop doesn't have the same power constraints. But on the phone, you really would like to know, is the user actually using the phone right now or not? And then depending on that, you can change the application behavior. Orientation is something that the desktop can have sometimes, and maybe you've seen these demos where people go like this with the laptop, and there's a website that displays information depending on that, or games. And there's actually really cool games where you can sort of tilt the phone and like a ball is rolling or something like that. And that's really cool. And it's really cool to be doing that on the web. And so, for instance, for this, for the orientation API and the vibration API, these are great examples of APIs that don't require you to be privileged. The configuration API is settings API is another one. Is another example of something that's very deeply related to the phone, though. So the settings API lets you change all of the settings of the phone, and so that, for instance, is an example of something that is very privileged. I don't know what the next one is.
It's block resources.
Okay, that's probably the device storage. I don't know.
Blocking the resources.
Probably device storage. It's a weird translation.
Blocking resources. Resource lock API. Okay.
Oh, resource lock. Oh, okay. Gotcha. Power API. Mobile connection. Yeah. Mobile connection, very useful if you want to display signal strength. Basically, everything you see at the top bar of your mobile phone, that's a mobile connection API. And Socket API. Socket API is another great example of a very privileged API that it allows you to make random socket connections to random servers. Very, very useful if you want to write an email application or something like that. I imagine very few people will need to do that, but we need the ability, if for those very few applications that do need to talk to random servers, we want to be able to do that, but on the other hand, it's a huge security gap if it's not done right. And so again, that's an example of a very privileged API. And there's so many more. And we've seen the Open Web Apps API in place and working a little bit. Navigator.mozapps.install if you want to install an API, etc. Bluetooth, NFC, they're still under work. Camera API, very interesting, very cool. I think that's actually an example of an API that I hope that a lot of people will use, and so forth and so on. Lots and lots of APIs, and even more.